Students, so welcome in this session of rational number for class 8. So let us see the sequential concept related to rational number. So first of all we will introduce and we will get the clear concept of a rational number, that what does it mean. So students, numbers which have form where p and q both are integers but q is not equal to 0, such numbers called rational numbers. For example, here you see 2 by 5, minus 3 by 7, 5 by minus 2, similarly minus 4, 2, 0, etc. all are rational numbers because all are having the form p by q and q is not 0. P may be 0 as we have taken the example of 0. So the question is 0 a rational number? Answer is yes, because 0 can be written as 0 by 1, 0 by 2, 0 by 3. Every time its value is 0, but the number comes in the form of p by q. Similarly, for minus 2 and minus 4, any integers, all integers are considered now as rational number because every integer has denominator 1 hidden in it. And if we want to write say minus 4, then we can write it minus 4 by 1. Similarly, for 2 it is 2 by 1. So every number can be expressed in the form of p by q. That say that all integers are rational numbers. Now these integers are both from negative, either both from positive or from one negative and one from positive. They all these numbers are considered as rational numbers. Okay, now standard form of rational numbers, it means when a rational number having only one common factor between p and q, and that is 1, no other common factor should be there in p and q other than 1, then number is said to be in standard form or in reduced form or in lowest form. Say if we take one example of rational number 12 by 15, no doubt it is a rational number because we have taken 12 in the place of p and 15 in the place of q. But although it is a rational number, but it is not written in standard forms because there is 3 which is common to both p and q. That's why when we make it smallest form, so we will cancel these two number by common factor which is present, that is 3, then it comes 4 by 5, and now between in the 4 by 5 which is standard form, and there is only one common factor between p and q, and that is 1. So any number said to be in standard form or in lowest form if there is one common factor between p and q, and that common factor is 1. Except 1, there should not be any other common factor. Okay, so now absolute value of rational number. Actually what happens, absolute value has a symbol of two vertical line. So when you see here, when we draw two vertical line and inside these two lines we write the number, then it is said to be that number is written in absolute value, and it indicates that you have to take now its absolute value. So it is also called modulus. Here we have taken some example that what is the absolute value of a rational number. So there is rule that any positive number is having absolute value equal to that number itself. For example, here we have taken absolute value of 2 by 5. Since 2 by 5 is a positive rational number, so its absolute value is equal to this number, that is 2 by 5. But there is another rule that for any negative numbers the absolute value is again positive. It means, for example, if we take absolute value of minus 3 by 7, then it comes 3 by 7. Similarly, for absolute value for minus 5, which is written as inside two vertical line, then since it is the minus, so absolute value will be positive, that is absolute value of minus 5 is equal to 5. Okay, so here rule is a positive number has absolute value equal to number itself, whereas negative number absolute value uh, is its positive value, that is ignoring the number comes is that absolute value. Okay, now we see uh, that how such numbers can be represented on a number line. Say we have taken one number 5 by 7. For this, what we will do, we will draw first of all a line, and then we mark the point for 0, and now you see this is positive, so its place will be right of the 0. That's why we have taken 0 in the left, and our number will have the position right of this 0. So we have kept more place for representing the number. Now we will take one division of our choice, and that will be called 1 by 7, because 7 is the denominator. Similarly, if we take equal another division, then it will be 2 by 7, again it will be 3 by 7, and so on. We will go up to 7 by 7, which is equal to 1. Now our number is 5 by 7, so here is 5 by 7 here. So we will write there some name of that place, say P, and now we just make the statement that P represents 5 by 7 on the number line. Similarly, for a negative number, say minus 3 by 5, what we will do, first of all we will draw a number line, and we will write 0 in this time in the right side, because our number is negative, and negative numbers are in the left of 0. That's why we have taken 0 in the right, so that we may have more places to represent in the left side. Now we take one division, that will be called minus 1 by that denominator, which is 5. Similarly, for second is same unit, it will be minus 2 by 5. For third same unit, it will be minus 3 by 5. And we don't live here, we go up to a complete integer, so we have to go up to minus 5 by 5, which is equal to minus 1. And since our number is minus 3 by 5, so we give here one name, say point Q, and then we make a statement that point Q represents minus 3 by 5 on the number line. Now if we want to represent two or more numbers on the same line, say we have taken one example here that represent 1 by 6, 1 by 3, 1 by 2, 2 by 3 and 5 by 6 on the same number line, then what we have to do? We should take the LCM of denominator. So it comes 6. It means our each division will have the value 1 by 6. And since all the numbers are positive, so we write 0 in the left side, and then for each division we will have 1 by 6 value. So first will be 1 by 6, second will be 2 by 6, which on simplification the same is equal to 1 by 3. Similarly, the third division will be for 3 by 6, which is equal to 1 by 2, and the fourth is 4 by 6, which is equal to 2 by 3. Similarly, we will go up to a complete integer, that is 6 by 6, which is equal to 1. Now we will give the name of these places, since we have to represent many numbers, so we will give names as say P, Q, R, S and T, and we will lastly we will write in the statement form that point P, Q, R and S, R, S and T respectively represent the number 1 by 6, 1 by 3, 1 by 2, 2 by 3 and 5 by 6. Okay, so now it is not difficult to represent any number. In this way you can represent the said number. Now we come to uh, some terms related to this topic, that is additive inverse. So for a given number, the additive inverse is that number uh, which on adding to the given number equals to 0. Then both of these numbers are said to be additive inverse of each other. As for example, the given number is 3 by 4, then we will have a number which on adding to this 3 by 4, the whole will become 0, and that number is minus 3 by 4. It means when 3 by 4 is added with minus 3 by 4, it is equal to 0. So we will say that minus 3 by 4 is the additive inverse of 3 by 4, and vice versa, 3 by 4 is the additive inverse of minus 3 by 4. Similarly, it means here what you are observing, that for a given rational number, if the rational number is positive, then its additive inverse is negative, but number is same. Similarly, for a given negative number, the additive inverse will be positive and number will be the same. For example, for minus 5 by 7, the additive inverse will be 5 by 7. Now come to another type of inverse, which is called multiplicative inverse. Its other name is reciprocal. Popular name is reciprocal. So it is defined as, for a given number, that number will be say told as multiplicative inverse or reciprocal, by which the given number should be multiplied to give result 1. For example, given number is 3 by 5, then we have to find out such a number by which multiplied to give 1, and that number becomes 5 by 3. It means when 3 by 5 is multiplied with 5 by 3, then it gives 1. So we say 5 by 3 is the multiplicative inverse of 3 by 5, or 5 by 3 is the reciprocal of 3 by 5, or we can say both numbers are reciprocal to each other. Okay. Now similarly, another example is here, 5 given number, then its reciprocal or multiplicative inverse will be minus 1 by 5, because then only it will give 1. So minus 5 and minus 1 by 5 both are reciprocal to each other. So here what you observe that here for a positive number the reciprocal is also positive, but number is reversed, and for a negative number then reciprocal is also negative, but here number changes, that is number become reversed, whereas in additive inverse number remains same, the sign just gets reversed. For a positive it is negative, and for number it is positive in case of additive inverse, whereas in reciprocal or multiplicative inverse the sign remains same but number get reversed. Okay, some notes are here that two numbers are who which are reciprocal itself, their own reciprocal, that is 1. For the given number 1 the reciprocal is also 1, and for minus 1 reciprocal is minus 1. So 1 and minus 1, these two are such a numbers uh, which are their own reciprocal. Similarly, another point to note down is 0 is only number which has no reciprocal, so its reciprocal is not possible. And the third point is 1 and minus 1 are additive inverse to each other. Okay student, now next we will see one very important question, that how we can find one or more rational number between two given numbers. So there are various methods of finding rational numbers lying between two numbers. Since between any two numbers there are infinite numbers, rational numbers hidden between these given two numbers, so we can find one or more what is required. But various methods are, especially when we need one or two numbers only, then we should use this formula that rational number between two given number is equal to half into a plus b. This is called average method. That is a and b are given two numbers, and multiplying it by half, it means we are getting the average. So half into a plus b. Say we have to find one number between 1 by 2 and 1 by 3, then one number is equal to half bracket 1 by 2 plus 1 by 3, and on simplifying we get 5 by 12. So in this way we can find one number between two given numbers very easily. Now so far, for more number, when we need more numbers between two given numbers to find out, then we should use the one easier method which is called a range expanding method. Here the important point is to note that the denominator of given number should be equal. If they are already equal, then it's good, then we will do the further steps required. But if initially if you see that denominators are not equal, then you have to make it first equal. How? Just taking their LCM. Say we have to find 5 rational number between 3 by 4 and 2 by 3. Since 3 by 4 has denominator 4, whereas 2 by 3 has denominator 3, so denominators are not equal, so we take the LCM, which is 12. Now we will make the denominator in both the cases 12 by multiplying it with a required number. But when we multiply, then our multiplication should be for both numerator and denominator. So here in case of 3 by 4, denominator to make 12 we have to multiply by 3. So we will multiply 3 by 4 by 3 both numerator and denominator. Similarly, for 2 by 3, to make denominator 12, we have to multiply it above and below by 4. So in this way we now get 9 by 12 and 8 by 12. So number got changed, but actually if we bring it in simplest form, then it is again the given number 3 by 4 and 2 by 3. But here you see, when we make the denominator equal, then numbers become 9 by 12 and 8 by 12. Even then between these two we don't get any number, because after 8 there is 9. So 8 by 12, then it is 9 by 12. So there is no number appear between them. Then what is to do? We just multiply both sides by 10 above and below to make the range more expanding form. So multiplying 9 by 12 by 10, also 8 by 12 by 10, then our number become 90 by 120 and 80 by 120. Now it appears that numbers change, but actually in bringing the smallest form, standard form, we again have the same number 3 by 4 and 2 by 3. And on expanding its range, since we have 80 by 120, then 90 by 120. So in between these two, there are so many numbers, say 81 by 120, 82 by 120, 83 by 120, and so on. So we may write the 5 numbers just starting from 81 by 120, 82 by 120, and go to 85 by 120. In this way we can have the 5 numbers. And here we just finish our topic. So these various type of questions what we have discussed in this topic, questions related to these concepts are given in your book. So definitely I feel that I do hope also that all of you are now able to solve the exercise question. Even then, if any doubt is there, we will share it in the next video. Okay, till then, goodbye.